Great. Okay, so run these lines of code. Again, everything's available at Teaching Are New if you don't have that on your computer yet, and get the surveys data into your computer. Can you put a green sticky up when you have the surveys data loaded into R?
I'm getting a message that says no such file or directory. I'm just trying.
So it's looking
Okay, so we have the surveys data. It's a data frame that has something on the order of 34,000 objects in it. Oops, let's see. Yes, 34,786 objects in it. And this is the same thing that we've been working with for the last few weeks. There's 13 variables. One thing we're going to do today, which we sort of touched upon last time, is we wanted to make a new object called surveys complete. So we're going to use dplyr to remove all of the NAs from the 3 columns that we're going to be plotting. You could leave them in there and ggplot will automatically remove them for you, but it generates a warning message and it's better to be explicit about what we're doing. So to start, I'm going to create a new object called surveys complete. I give it my assignment arrow, and then I'm going to take surveys, pipe it into filter, and then I want to filter everything that is an NA, so keep all the things that are not NAs from the column weight. And I'm going to do the same thing and filter out all the NAs from the column hind foot length. And then I'm going to do it again one last time and do filter exclamation point is.na and then sex. So this is going to find the is.na function finds all of the NAs in the weight column, and then this exclamation negates it. So we filter out all of the NAs in weight, hind foot length, and sex. And if we run this, we see that our new object, surveys complete, is now 30,676 rows long, which is a little bit smaller than it was previously. Is it too small?
I'm nearsighted and I forgot my glasses, so
okay.
Just coming closer.
Does anyone else need it bigger? Okay. Can you see?
Yeah.
Okay, great. So now that we have our data that we're actually going to be plotting, let's start with making a ggplot. And we're going to make a scatter plot here. And this is going to be very similar to some of the plots that we've made in the last couple weeks. So I'm going to use the ggplot function. I'll give it my data surveys complete. And then inside the aesthetic, which is the thing that we use to designate the data that we're actually putting onto our plot, I'm going to say x is equal to hind foot length, y is equal to weight, and then I'm going to put a little plus sign, which designates that I'm adding a new layer to this ggplot. I'll use geom_point to generate a scatter plot of this, and I'm also going to go ahead and set the alpha to 0.1 because we have a lot of data that's going to fit onto this plot, and I want the transparency of the overlapping points to let us know about sort of the density of all those things that are overlapping so much. Oops, not a pipe. And then a plus sign for the next layer. And then the last thing, because I'm particular about my themes, I'm going to add theme minimal because I really hate that gray background that ggplot does automatically. So if I run this, does this look familiar to any of the plots that we generated in the last couple of weeks? We have a scatter plot with hind foot length against weight. Hind foot length is on the x-axis and goes out to about 60, and then weight is on the y-axis. And we see that some of our points are quite transparent because there's not very many points that overlap at certain locations, but other ones of them are overlapping a lot, and those are where we have a lot of data all at once. Okay, questions about this basic ggplot that we're going to be iterating on? Okay, let's start with titles, captions, and subcaptions. So I'm going to press Control-Shift-R, and that's going to give me this section label thing that pops up. I think Command-Shift-R also works, and I think it doesn't matter if you're on a Mac or a Windows. So with Control-Shift-R, I can now create a section label and say titles, captions, and subtitles, which was a really interesting way, sort of backwards ordering, but we're going to move on from that. Okay, so I'm going to copy and paste this basic plot that we generated. So if I copy these 3 lines of code and paste them down here in this new section, if I ran it like this, it would generate the exact same plot that we see on our bottom right-hand side. But I'm going to add a new layer, and this one I'm going to use labs, which I think we saw last week. And I'm going to say that I want a title, hindfoot, length versus weight. This is not a terribly informative title, but it'll work for now. Okay, so now we see that the only change to this is that we now have a title on our ggplot. That's not incredibly exciting, and I think you guys might have been able to have already done this before. I think we did it last week. But within labs, we can also add other information. So ggplot supports subtitles as well. So if I start typing subtitle, we see that this pops up, and it finishes subtitle, and it says the text for the subtitle for the plot, which will be displayed below the title. Okay, so I want subtitle, so I press tab. And then a good subtitle, I think, is saying what data this comes from. So I'm going to say this is our surveys data. And now if I run this, we see that there's a title, and then it's automatically been formatted where the subtitle below it is a little bit smaller, but it still looks nice.
What's your data frame? Survey data is your data frame.
That's where our data came from. This is the surveys data. Or we could have said all the animals moo ha ha. You can say whatever you want. But I thought surveys data might give us a little more information about, like, let's say the surveys data was taken from, I don't know, does anybody know the locality in the world where this was taken?
East Coast, Portland, Florida.
Taken from East Coast, USA.
It's US, I know that.
Maybe. Just something that gives the reader a little bit more information about what this data is. Okay. Then the other thing that ggplot supports is within this labs function still, if I put a comma after our last argument, so I'm actually going to make this a little bit shorter so it doesn't run off the screen. I can also put a caption. So for example, I could say that the data was collected from 1977 to 2002. And then this caption will appear down here. And it's smaller, but it still has information about this plot. And I looked at our surveys data earlier and figured out that that this data was collected from 1977 to 2002. So that's information that's inside of the data frame that in order for me to write this, I looked inside of it, looked for the minimum number, it was 1977, looked for the maximum number, it's 2002, and then I wrote it on there. How do I make that go away? There we go. So that's great, but what if you had to generate like 100 of these plots? You don't want to have to go into your data frame every time and figure out what that information is. So the nice thing is these titles and captions are also scriptable. So we're going to work on doing that now. So how would I get, using R, how would I get the minimum year in this data frame?
Group by year and summarize or something?
Yeah, you could group by year and summarize. I'm going to use the function min. And this is a base R function. So to do that, I have to do surveys complete. And then I'm going to do the $sign operator, which allows me to access our different columns. And if I scroll down, I see that year is one of them. And if I run this, I see that the minimum year is 1977. Okay, using the same syntax, how do you think I'd get the maximum year? Max. Yeah. Okay. So if I use the max function here, I'm really bad at spelling surveys. It's one of the saddest things because this is all over that lesson. Okay. We do surveys underscore complete, $sign operator again, and then year, and we see that it's 2002. Okay. So this is a way to access that information from this data frame. So we now have a way using R to figure out what the minimum and maximum year is. But now we want to format this so that it looks a little bit prettier. So to do that, I'm going to use format the min and max years so it's pretty for the caption. I'm going to use a function called paste zero. So what paste zero does is it takes two strings or two numbers and it pastes them together. And it does it where there's no separator, so there's no spaces or anything like that. So let's try that let's paste our min year and max year together. So if I do paste zero min of surveys complete, $sign year, and then max of surveys complete, $sign year. Because this doesn't, paste zero just logs two things together and it doesn't add spaces or anything like that, we got 1977, 2002, which is okay, but we can make this a whole lot prettier. So we could take this paste zero command and we can add to it a little bit. So our caption currently says data collected from, so we could add this string, so data collected from, put a comma after it, and I'm going to put a space at the end of this string as well, because that will, when paste zero works, it will have the space already built in so that this looks a little bit easier to read. Then I want to put the minimum year because it's data collected from 1977. And then the last thing that I'm missing is a little dash with two spaces next to it. So if I run this now, I get data collected from 1977 to 2002. So if we wanted to add this to our plot, we could do ggplot, surveys complete, AES, x is equal to hindfoot. We can also copy this from above, but I felt bad doing that, so I'm typing it out. Y is equal, that's not true. Yes, it is. X is hindfoot length and Y is weight. A +sign, geom underscore point, a new layer with a +sign, get rid of the icky gray background that I don't like. And then let's add our caption. So we could do labs. Caption is equal to paste zero, data collected from space, then a comma, and then I want the min of surveys complete year, and then outside of that parenthesis, so after our min function, I'm going to put a comma and then a space dash space, then after that another comma, and then max of surveys complete year. And now when I run this, it looks exactly the same, but this will auto update for you. Yes.
I figured out where the data's from.
Where is the data from?
It's from Arizona.
Arizona,
It's
it's
in the
southwest.
Chihuahuan Desert.
Well, we better add that.
It's called portal data. It's from your portal,
Portal, Arizona.
which never knew. Pretty cool.
All the years.
They apparently also, it's like a huge long-term monitoring. Yeah.
Okay, so our subtitle is going to say near Portal, Arizona, and then we'll have our same caption.
Nice.
So I use this a lot, especially this little caption down here. Maybe I don't actually care about year, but you can do this in the same way. You can calculate the mean of your data or your standard deviation or something like that, some metrics that's important to the plot that maybe adds understanding or makes it slightly easier to interpret. I like to use the caption for that. And it might not be something that I put in a paper, but it's something that I give to my advisor or I use for myself as like an exploratory data analysis thing to like keep track of all of the different things that there are to keep track of when one is doing a data analysis. Questions about titles, captions, plots, and scripting them? Okay, so the next thing I want to show you is on annotating our plot still, if we want to label some points. So I'm going to put another section header with Control-Shift-R and say labeling points. And this time we need to install a package called ggplot2. So I'll use the install.packages function to do this. And then in quotes, give it the name of the package, ggplot2. I already have it installed and it's actually already probably loaded, so it might sort of mess up my session if I run that. So instead I'm just going to run library ggplot2, but I'll give you guys a second to install this. So go ahead and throw a green sticky up when you have the library loaded. ggplot is really great and it allows us to do a lot of really fancy things with plots. But there's also a lot of people in the world who have decided that ggplot does not do everything that they need it to do. And they have built packages that make ggplot even snazzier than it already is. A lot of these start with gg, or so there's like ggrepel, ggtext, gg, I don't know. There's a lot of them. And they allow you to have additional functionality to make your plot pretty. So the ggRepel package allows you to label the data points on your plot, but it'll automatically repel the text from the point that it's labeling so that it's not overlapping with the data or other labels. So you could already have labeled the points in your plot, and we were actually going to walk through and do that until I realized that there was 30,000 points on this data frame, and it like crashed my computer this morning. We're not going to do that. Instead, we're going to figure out a way to label just the outliers on the top of this plot. So we're going to work on labeling these ones in a nice way so that we can see what species these come from. Or we could do these ones. Who wants to label the weight outliers? Who wants to label the hindfoot outliers? Nobody cares. Hindfoot outliers. Okay, we will do this one, these two, or that one. We'll see what comes. Okay, so we're still going to be working with this same plot. Do you guys mind if I copy and paste the plot from above? These first 3 lines? Okay, I'm going to copy this same plot that we've been working with. I realized that we dropped our alpha, so I'm going to add that back in. Alpha is equal to 0.1. And now with our library ggRepel, I'm going to add a layer, and this time it's going to be geom_text. And I see that I have 2 options that RStudio prompts me with. The first one is geom text, and that's from ggplot2. And what that says is it will add text directly to the plot, which is great, and that would label directly where your points are. Now we see right below it, there's geom text repel. And if we look at this little help message, it adds text directly to the plot, but in the help message, it would make it, the text labels repel away from each other and away from the data points. So this is a little bit of added functionality so that we don't obscure the data when we add these labels. So we'll do geom_text_repel. And to make this an actually good teaching exercise, we would run this right now and you would see what this does and all of the points would be labeled. But as I said, this would crash our computers. So we're not going to do that. And instead, we're just going to increase our cognitive load, and I'm sorry, and go directly into looking for outliers. So within each layer of ggplot, you can either inherit the data from a previous layer. So that's what we do from line 77 to 78. On 77, we set our data as surveys complete. We're taking the columns, hindfoot length, and weight. And because we set these globally, they're inherited by geom point, and that is what geom point plots. For geom text repel, we're going to do something a little bit different, and we're going to reset our data. And this time we're going to filter surveys complete, which is our dplyr command. And we're going to do hindfoot length is greater than 60. So I can tell by eyeballing this plot that there's only one outlier really here in hindfoot length that's above 60. So this should be the only point that gets labeled. If I knew a little bit more about the data, potentially we could set it at like whatever this is right here. And then these 5 would get labeled. But I don't want to risk it because that border's like a little close and I want my computer to keep working throughout this whole presentation. Okay, so that's our new data. The data that is going into this layer for geom text repel is anything in surveys complete with a hindfoot length greater than 60. So that should only be 1 point, and that's the data that's getting plotted here. If I put a comma after that argument, we have to redefine our aesthetic since we redefined our data, but in this case, it's still going to be hindfoot length and y is equal to weight. And then I want to label it, and this time I'm going to label it with species ID, which is another column in the data frame. Because I want to know what species that outlier point comes from. So if I run this, that was unexpected. Okay, so that was unexpected. Yeah. Oh, I see. Yep. That should work. Is that what you're going to say?
Yeah.
Okay. I'll explain this once it works. Great. Okay. So the reason that didn't work is because the aesthetic inherits from the data that we set. So the aesthetic knows to look within the data that we gave it for the things that have column headers starting with like weight or label or species ID or whatever. So we don't need to specify what data they come from because we already did that by setting data at the beginning of the ggplot command. If I go outside of the aesthetic, ggplot no longer knows to look inside the data. So then it was looking for an object named species ID, and we don't have an object named species ID. We just have a column named species ID. Does that make sense why that failed? And then why it worked subsequently? Okay. So if I zoom in on this plot, we see that none of our data is covered by this label, but this point is associated with that label. When those associations aren't clear, geom text repel will put a little line to which point the label belongs to. It didn't need it in this case. So this can be a really nice way to label outliers on your plot. Questions about that? We can also change this to geom label repel. And then the formatting just looks different, where this is now a label instead of text. So you get to decide, choose your own adventure, which one you like better. Okay, so then the last thing that I want to show you is how to make an interactive plot, which, Ryan, did you go over this?
Yep.
Yay, okay. So Control-Shift-R for a new section, and I'm gonna name this one Make Interactive Plot. And again, we need another library to do this. So I'm going to do install.packages and install Plotly. And then I'll load the library Plotly. There we go. And we see some things were masked. We don't really have to worry about it, but our package Plotly is now attached. So I'm gonna copy this plot that we've been working on and paste it down below. And the only change, I'm gonna make two changes to this plot. The first thing is that I want to assign it to an object. So if I do this, I'm going to assign it to something called PLT, which is not the most informative object name, and maybe we should choose something better, but we're not going to. If I run this, we see that nothing really happens, but now if I run PLT, a new plot pops up in our plot viewer. So this plot is now saved in this object. And I see that in my global environment, I now have a new object called PLT. It's a large GG with 9 elements, but basically it contains all of the data to make this plot. The other change that I want to make is I'm gonna add a little more information here. So inside of this aesthetic, I'm gonna set the label to species ID. So we have X is equal to hind foot length, Y is equal to weight, and label is equal to species underscore ID. And if I run this again, it'll save to our object PLT, and then I'll plot PLT. Nothing happens. The reason why is because we didn't add a geometry that knows what to do with these labels. So if we had added geom text or used our ggRepel, those labels would get added to that plot because now they have this association by setting the label. But since we didn't use a geometry that takes advantage of that information is still in the plot, we just can't see it. But there's a cute little function called ggplot2 that can see it. So if we use ggplot2 and then type PLT, so we give it that plot object, and give it a little bit of time because it's making an interactive HTML plot. This looks a little different than it did before. I'm going to click this button here to have it launch into my browser. Just give it a second to load. Okay, we now have an interactive plot. So if I hover over any of these labels, I see that it's hind foot length 39, weight is 120, and my species ID is DS. I can also decide that I don't care about all of this information. Sorry, my computer's being really slow. And I can zoom in on a specific section of the plot, and it'll zoom to just that section. And then I can look at only those labels. So this is an HTML, which means that it won't work like in a, I don't think you can embed HTMLs in a PDF. You probably can. I don't know how to do it. But it'll work as an HTML document. So you can use this in your own research as an exploratory data analysis, or you can send it to collaborators. I often find if I'm sending it to to one of my PIs, that I explain like, please open this file in a browser. It's an HTML document. It will render from your computer and then you can click on things. But otherwise, sometimes people get a little confused if I don't tell them that first. So I don't really use these for like publication quality things, but they're really, really nice for exploratory data analysis, especially when you have a lot of data points to try and find patterns. Questions about that?
that to the full plot.
I'm pressing this zoom out button.
Just have to keep zooming out until it's.
There's a button that allows you to like go all the way back out all at once. Where is that? Oh, there we go. Reset axes. Thank you. It's like, I swear I've done this before, but I can't remember. There we go. Yeah, the home button will allow you to go back to the whole thing. If you want to play around with this a little more and your computer is slow like mine, you can try, instead of plotting 30,000 points, plot like 300 points, and it'll be faster.
Oh, so you could use slice in like the first 200.
Yeah. Okay, questions about that? Yes.
So can you use this functionality without access to the internet?
Yes. Yeah. So the question was, can we use this functionality without access to the internet? Yeah. So what ggplot2 does is generate an HTML file that has all of the information inside of it. And HTML files are best rendered by browsers. So browsers know how to interpret all of the text that's in HTML to make a pretty picture. But essentially all Plotly is doing is generating a really large text file that has all the information in it that's hosted locally on your computer. Okay, thanks for coming.